In this short video, we're going to go over first-degree price discrimination using a graph to illustrate it. So let's start by drawing our standard graph where we have price on the vertical axis and okay, so in this short video, we're going to go over first-degree price discrimination graphically. Let's start by drawing our standard graph where we have price on the vertical axis and quantity on the horizontal axis, and I'll start by drawing the inverse demand curve. Okay, and then let's also draw the marginal cost curve on this graph. I guess I'll draw that in blue. For simplicity, I'll just assume that marginal cost is constant, so this is just a flat line, or supposed to be a flat line. Okay, so what happens under perfect first-degree price discrimination? Well, we assume in this case that the firm knows exactly how much each consumer is willing to pay for each respective unit that they buy. So the person who's at this sort of top point on this demand curve, we know what they'll pay, and so the firm will charge them exactly that. And the price is equal to, the height of the inverse demand curve at that point, and so the revenue is, it's just it's like a tiny little rectangle. This is the revenue that they get from selling to the first person, and then the second person they'll charge them the price that's equal to their willingness to pay, and so on. And if you add up the profits from each of these individuals, where the profit is equal to the height difference of the inverse demand curve for that person minus the marginal cost, and you add all those up, you'll get that the area that equals the firm's profits under perfect first-degree price discrimination is equal to this triangle above the marginal cost curve and below the inverse demand curve. Okay, so you can view this area, this shaded area, as the entire surplus that is usually could be split by the firm and consumers, or some of it could be part of the deadweight loss area. Under perfect first-degree price discrimination, the firm extracts all of the possible surplus in the market. This, in a sense, is efficient in that there isn't any deadweight loss area, but it doesn't seem particularly fair to consumers. However, there is one advantage of it in that it gives the firm the full incentive to innovate, right? If some innovation is rather expensive, as long as the cost of innovating or creating some new item is less than this red area, then they will innovate. So let's look at what happens if the firm can't first-degree price discriminate. Then we have the standard monopoly problem. So let me draw the marginal revenue curve. Remember, that's going to have the same intercept and twice the slope as the inverse demand curve. Okay. The firm, if in this case, is going to choose a quantity of output where marginal revenue is equal to marginal cost, and charge a price, if it's charging everyone the same price, equal to the height of the inverse demand curve for that quantity. And then this area here will be the firm's profits. Purple area will be the consumer surplus in the standard monopoly case. And this lower triangle here will be the deadweight loss area. So we can see here that the firm earns lower profits, which might give it less incentive to innovate when it's unable to first-degree price discriminate. Of course, that does benefit to consumers in a way because they're left with some surplus. So, overall, it's unclear whether first-degree price discrimination is a good thing or a bad thing. It does reduce the deadweight loss area, but it does not leave consumers particularly well off. While this idea of first-degree price discrimination is nice in theory, it is unlikely to be feasible in practice for the reasons that we usually state, that we do not believe that firms are able to know exactly how much consumers are willing to pay. As I said before, consumers are going to try to hide this information, at least if they're high valuation consumers. And so everyone will say they're a low valuation consumer, whether or not that is true.